Hi, today I will show you the most simple breadth first search algorithm for this problem number 102, binary tree level order traversal. So what we need to do is take a binary tree, and for each level of the tree, we need to push the values into an array, but those values need to be arrays for the entire level. So let's look at the algorithm. First thing, we check if root is null. If it is, we return an empty array. Because we need to return for this problem, we need to return a number array. Okay. And the next thing we do is we declare two variables. One of the variables will be our queue. Inside of our queue, we're storing our nodes, and those are going to be reference objects. So each one of them, this is a key point, each one of these reference object will have a dot val, a dot left, and a dot right property, okay? Whereas our answer array, that is going to be the array containing arrays of numbers, okay? All right, so we're going to use the queue's length. So as long as there's something in the queue, we're going to run this entire loop, and there's another loop inside of it. But let's see what happens up here first. So we first declare a variable queue length, which is also the same thing, but we're going to use it to decrement in our next loop down here. So the last thing we do before getting into this loop is we do a clever method inside of we want to push the values from each level into our answer array, but we need to make those values into an array. So we use the dot map method, which returns a new array, and then we just push that in. So for this level, there's only a 3 in it, so we'll go for each node. We create an array with the node's value in it, and it will keep doing that for as many nodes are in the queue. All right? And so in this case, we just push a 3 onto it. All right, now down here, we're gonna go and we're gonna decrement queue length by 1 each time. And each time we do that, we declare a new variable called node. And this is another clever use of a method, a JavaScript method, is for each time we do this, our node is removed from the queue. This shift method removes it from the queue from the beginning of the queue. So whatever one was inserted first gets removed, and it's stored in this variable because this returns the element. And what is returned is, again, a reference object. So that means this node has the properties dot left and dot right on it. So the next two if statements check if those exist. If it's 9, there won't be anything there, so you don't do anything, we just skip it. If it's 20, we actually just push the new values back into the queue, which increases the queue length and continues this entire process. At the end, we just return our answer. Time complexity is big O of n because we have to go through every node, and same with space complexity. Let's go through our algorithm step by step. In the first case, we use root in our queue, so we set queue equal to root, which again is a reference to a node object with a value 3. Answer is set to an empty array. The queue length is 1. Queue length, again, we save it in a variable, it's equal to 1. And then we push onto our answer array the value of 3 from this node inside of an array using that map method. Okay, while our length is still existing, so this is the only iteration since it's 1, next it will go to 0 and it will stop. So we're going to declare this node variable and set it equal to roots node, okay? So it's equal to that node object, and we check the left and the right. We have a 9 and a 20. Both of those nodes are pushed onto the queue. So our queue looks like this now. Now let's go to step 2. In step 2, our queue looks like this. 9 and 20 are inside. When inside of the answer, we have an array with 3 in it. All right. Queue length is 2 right now. And we push, again, we're going to push what is inside of the queue onto the answer array as its own array using that map method. So answer will look like this, perfect. And we're going to go and this time queue length is 2, so we have 2 iterations. The first one, we check the left node. The left node has nothing, we remove it from the queue, and that's all. Then we check the right one, and the right one has 2 children, the left and the right. So we remove it from the queue, and then we push its children onto the queue. The queue looks like this, 15 and 7. Let's go to step 3 now. Okay, now queue is 15 and 7. Answer is 3, 9, and 20. Great, and each one of these is, this is the root level, and this is the first level. Again, queue length is 2. All right, so we're going to push on this time the children, the whatever is in the queue, 15 and 7. The answer looks like this. We have 3 subarrays in our answer array. And length again is 2, so the first iteration, we just pop off our 15 or shift it off, and there's no children. And then the second iteration, we shift off our 7 and there's no children, which brings us to our last step. And now the queue length is 0, so we stop and we just return our answer. That's all.